So this is a new function. You haven't seen it before, but it's a lot like the one that we've been doing. It's called the square root function, but it's very similar, and we're going to think about it in very much the same way that we were doing parabolas or quadratics. Okay. What does it mean to take the square root of something? We're going to draw the parent graph first, so let's see what it looks like. But think about what it is. It's y equals the square root of x. X is the input, y is the output. So I get to choose my x's. So let's start with 0. What's the square root of 0? You can use a calculator for this, but maybe some of us know it off the top of our heads. What's the square root of 0? What number times itself gives you 0?
0.
0, right? Square root of 0 is 0. Very good. What if I put in 1? Square root of 1? 1. Get your calculators out. If you have a calculator on your desk, help me out with this. Do the square root of 2. Madison, what'd you get? Yeah, decimal, nasty. We don't want to graph that. So the difference between the square root function and quadratics is we're going to pick our x values in a smart way. Okay? So we're going to pick the right x's to use. But it's going to be easy to remember what they are once you see what this graph looks like. So 2 is no good. What about the square root of 3? Is that any good?
Decimal.
No good. What about the square root of 4? Does anybody know? Nick, do you know what it is? It's 2. So let's pick 4. What's the next number that you can take the square root of? 9. Very good. So let's pick 9. And the square root of 9 is 3. Do you recognize these numbers at all? Aren't those the outputs of the quadratic? When I square 1, I get 1. When I square 2, I get 4. When I square 3, I get 9. So we just flipped them. That's all we did. Because now we're graphing the square root of something, but we want to pick good values that you can take square roots of. We want good things to graph. You could graph the square root of 2. 1.4 is just below 1.5. You just estimate it, but it's way better if we choose the right numbers. What about the square root of -1? Do that on your calculator. Error. Why? Do we know why? This is like an aside, but we can talk about it for a second here. Square root of 25 is 5 because 5 times itself is 25. So the square root of -1. What number times itself gives you -1? Well, -1 times 1 is -1. 1 times -1 is 1. Oh, sorry, -1. But that's not a number times itself. Those numbers are different. Okay, so 1 times 1 is +1, and -1 times -1 is +1. Like there is no number multiplied by itself that will give you a negative. What's the square root of -25? Error. It's not 5 times 5. Because you're always going to have no negatives or 2 negatives. So you can't take the square root of a negative number. You talked about this a little bit in grade 10 probably. It might have come up a tiny little bit when you get, because once in a while you get a negative under the square root sign. But you can't do that. So this graph starts at 0. We can start plotting these points now. We got 1 and 1. Then we go over 4 and up 2. Then we go over 9 and up 3. And none of the values go below, because when I take the square root of a number, I'm not going to get a negative either. And this is what this graph looks like. Like that. So what does it look like? It looks like half of a parabola, but lying down. Don't graph both. It's not a full parabola. It's only ever half. What do you think about that? Easy enough because we know a lot about parabolas and we've done that for a couple of days. So we're going to do this for a day, but it's a little bit of practice of everything. So it's pretty good. We can easily graph any new, whoops, there's some mistakes on this page because it was like copied from the last one and then some things weren't fixed. Any new square root function. You don't necessarily have to change them all if you want to be lazy because you know what it means. So take a look. I've got my A, I've got my H, I've got my K. It looks a lot like y equals A x minus h squared plus k, except instead of brackets and squared, I've got a square root sign. And we're not going to write all of it down again. I don't think it's worthwhile. It's all the same as quadratics. So the A stretches and compresses vertically. If A is big, it's a stretch. If A is small, it's a compression. If A is negative, it flips it. It's a reflection in the x-axis. H shifts the graph left to right. What's wrong? You okay? H shifts the graph left and right and does the opposite of what you would expect. And K moves it up and down. What's wrong? I can only help if you tell me. Reflection in the x-axis, yeah.
If it's negative.
If it's negative. Yeah. Okay, thank you for cluing me in. Yeah. The learning goal had a reflection on it. Okay, so we're going to do the same thing. We're going to do the exact same thing. To graph, we're going to find the vertex first. So it's just based on the shifts. And then we're going to think about if the graph is stretched or not and use that same pattern to find the other points. So let's take a look at this. So see how there's mistakes here again. So we got to scratch this out. And we got to do y equals, we'll do the square root of x plus 3 plus 2. So the first thing we can find our A, we can find our H, and we can find our K. Because you got to get used to where those values are depending on how the equation looks. Does anybody know what any of them are? The A, the H, or the K? Want to take a guess? Brooke? A is 1. Very good. Zach, what do you think?
H is -3.
Very nice. H is -3 because it's not brackets this time. It's the square root sign, but it's the same idea. So, and it's the opposite sign. And so K is going to be 2. Thank you. So I've got a shift to the left 3 and up 2. So if I want to graph this, I'm going to draw my axes like this. Let's see. This will be lots. Uh-oh. Oh, stop snapping. Oh, there we go. And I'm going to draw my axes like this. We're shifting to the left 3, so I got to make sure I can go over 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. 1, 2, 3, 4, negative 5. So I'm shifting left 3 and up 2. I'm going to find that point, left 3, up 2. And who remembers what our overs were? Remember, they changed. For a parabola, we were going over 1, 2, 3, but this time we want to pick them in a smart way because 2 is not going to work very nice. So we're going to go over 1, and then, thank you, 4, and then 9. And we're going to go up. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. If you want to just watch, you can watch. Over 1, up 1 from the vertex. Over 4. 1, 2, 3, 4, up 2. And over 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. And it sure looks like a parabola to me. Except it's lying down, it's only half. What do you think? No, I don't believe you. You're wondering something. Okay. Alexis, what are you thinking? Just thinking about it?
How do you know that it goes to the right is because it's the negative 3.
It's always going to go to the right. They can go to the left. We're not going to look at graphs like that. You know how the A value can make it reflect in the x-axis? There is something that will reflect it in the y-axis.
Like if it was a negative one?
Not a negative A value, though. It's a totally different letter. Okay, so that's something that you could explore. We're just not going to worry about it. So there's something that would flip it that way, but that we're not going to worry about that today. So it'll always go to the right, but it won't always go up. The A will sometimes make it curve down. All right, let's try another one. Let's fix this. Let's do y equals 2 square root of x minus 4. Let's make it negative 2. What's my A? What's my H? What's my K? A is negative 2. Very nice.
H is 0.
H is 0. I love it because it's plus or minus nothing inside the square root sign. That means K is? Jessica, what do you think? K, what's K? So we got A is the negative 2. H is 0 because there's nothing inside the square root. So what's K? You got it. So I'm shifting down 4. I'm not shifting left or right at all, but I have a reflection and I have a stretch. So when I make my axes, I think I can make them like this, like up kind of nice and high. And I can make them over to the side like this. Down 4 and going down. So I might need some room down at the bottom of this graph. I don't know. Six, 7, 8, 9, 10. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. Oh, we can find our point. So I'm not shifting left or right at all, but I'm shifting down 4. So my graph is going to start there. So I'm going to go over 1 and pick these in a smart way, over 4, over 9. Oh, down. Doesn't really matter if you forget to say that's down, but I'm going to go down. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. But I'm going to multiply those by 2. So that's 2. Oh, why did I write 9? 3, 2, 4, 6. And again, that means these are the ones that I'm going to use to find my new points, right? If you're still kind of thinking about the stretching, because I know that this is a little bit different. This is where the points would be without the stretch. I'll do them in a different color. You don't have to copy them down, but they'd be there, there, and there. They would be those purple points. But I'm going over 1, down 2, over 4, down 4, and over 9, down 6. So whoops, that's 3, 4, 5, 6. So see how this has stretched. It has stretched the graph vertically from where it would have been. Because I would have, from here, gone down 3, but instead I'm going down 6. Because I'm multiplying those, because it's vertical, so I'm multiplying those by 2. Yeah. Jada, you had your hand up? Are you good? Are you sure?
No, I'm not good.
No. There's something about it that you're not sure of?
Yeah, why don't we, like, I feel like this is way different than the one we just did.
Right. It is because 2 is still a vertical stretch, and this is lying on its side. So vertical for this one is different.
Right, okay.
Yeah, you're right.
Okay.
So what if you took a parabola? I think I talked about this. What if you took a parabola, the one we were doing the last couple of days, and stretched it horizontally? What if you did that? Right? You don't stretch it up, down. You stretch it out. That's kind of like what we're doing. And again, you can do that. You can stretch things horizontally as well. It's just not something we've talked about yet. Any questions about this? Let's fill in the details. So we've done this at least once, and then I'm going to let you try one and try some of that other review. So transformations applied to the square root of x. We had a reflection in the x-axis. We had a vertical stretch by a factor of 2. And I believe a vertical shift down 4. We didn't shift left, right. So my vertex is still at 0, but it's down 4, so -4. Direction of opening is something you might not always talk about with square root function, but I guess you'd say right. It's opening to the right. Growth pattern, we already did that. Now this is interesting as well. We're not gonna worry too much about this, but this graph actually has a max min x and a max min of y. It has both. So we're going to talk about the y's. So this one has a max. I'll go back up. Let's take a look at the graph and see. This graph starts here and goes down forever. But it never goes above that point there. So it has a max of -4. And the domain and range of these are really interesting because they have restrictions on both. So x is an element of the real numbers such that, this is great practice for our quiz tomorrow, such that what? Is x always bigger or is x always smaller than something? X's start here and go that way. Is that getting bigger or smaller? Getting bigger. So it has something that it's never goes smaller than. So x is always bigger than, and it's at 0, right? So x is greater than or equal to 0. And the range is y is an element of the real numbers such that y is, so it has a maximum, so it's always getting smaller, so y is always going to be smaller than -4. Okay, and that's it. No axis symmetry for this one. That's it.